Okay, so we are going to find a side length. That is super important. So if we're finding a side length, you're not trying to find an angle, which we are going to in a little bit, but we're not trying to do that right now. So we're trying to find a side of a right triangle only. So everything we do in this unit is going to be right triangles, given two sides. Okay? So in a little bit, we're going to be given two sides, and I might ask you to find an angle. That's not Pythagorean Theorem. Maybe I give you a side and an angle, and I ask you to find a side. Not Pythagorean Theorem. You're going to use Pythagorean Theorem to find a side given the other two sides. Okay? Okay, so the first two sides, the A and the B, those are the shorter two, are called the legs. They are kind of irreversible when you put them in the formula, or reversible when you put them in the formula. And then the hypotenuse, that's the important part. Okay, so the one across from the 90, that's the important one. That's called the hypotenuse. Okay, it should not be news to anybody. We've heard those words before, but we're just getting them down. And for any right triangle, you can write it this way, which is going to help us with what we're going to do at the end of today. So c squared equals a squared plus b squared, or the way we've been writing it all semester is a squared plus b squared equals c squared. Okay, so kind of reversible as to whether or not you put the c squared first or the c squared last. Okay, okay, so our goal today is to be able to do these first four problems efficiently. Okay, so you all have a calculator, right? Phones down, calculators up, and we're going to do the first problem. The question I'm going to ask you on all of these first four problems is, are you going to add or are you going to subtract in your calculator? Okay, here's how you know. Okay, so we're going to do the first two so that we can have that discussion about adding and subtracting, and then we're actually going to type it into our calculator. So when you're doing this, the C, right, is always the one across from the 90, and that's really the only one that matters. That one has to be by itself, and then the other two are going to be together. So I'm going to do this. I'll go 8 squared plus 13 squared is equal to x squared. Okay, that should seem familiar, right? We're good with that. Now, what I do not want you to do, I do not want you to write 64. I do not want you to write 169. I want you to grab your calculator and type in 8 squared plus 13 squared and get me an answer. Okay? If you can do that in your head, great. If not, don't take the time to write that step down. Let's become more efficient. Okay? Okay, so with your calculator, we're going 8 squared plus 13 squared, and you get the number 233. Sorry, that is super dark. So 233, yeah? Okay, so what I have is I have 233 is equal to x squared. What are you going to do next? Square root. So you can also go ahead, when you write that 233 down, you can go ahead, you know what's next is going to be square root. And that's going to be my answer for x. So we're getting a little bit quicker. We're kind of cutting corners a little bit. But we're getting quicker and more efficient at this because as we go through, we are, in a little bit, going to have to find the area of a hexagon. And in order to do that, you might have to do a Pythagorean theorem. I want you to be able to do that quickly so that that's not something that takes up your time. It's the area that takes up your time. Okay, so we need to make sure we're efficient and quick at this. Okay, so the square root of 233. Now, I want to show you some other buttons on your calculator to help you be quick and efficient. My light is not doing so well today. Okay, so right here, we all know how to do second square root, right? So second square root. Get that on your keyboard. It's flashing. Have we talked about this yet? This negative button down here? So at the very bottom of your calculator, there's a negative button. And right above the negative button, no matter what calculator you're using, it says 3 little letters, A-N-S, right? Okay, so what you're going to do is you're going to hit second to be able to access that button. And then you're going to hit that A-N-S, that negative sign for that A-N-S. Okay. What that did was it took this answer, that 233 that you have above here. I really wish this was showing up right now. I think my light's going dim. There's a little bit better. There we go. So what that did is it took that 233 and it put that in there. Okay? That might not seem like a big deal right now. Okay? But in a little bit, what happens if this number, this 233, was 1,256.557? Okay? So what you're doing is, instead of typing in 156. You're going second square root, second answer, and you're done. Okay, so it's a lot faster, it's more efficient. We hit enter, and there's our answer, 15.26. So x equals 15.26. Okay, that is what we are going to do if the directions say to round your answer, right? If the directions do not say that, we are going to simplify the radical, which we practiced 2 days ago. Okay, so we're not going to worry about simplifying the radical today. We're just going to worry about being efficient, being quick, and doing the nearest tenth. Okay, so the next one. Let's flip over to the next one. Okay. When you type this into your calculator, or even when you write it down, are you going to be adding those two things together, or do you think you might subtract them? We don't really know what subtracting is yet, but is x your hypotenuse or not? Yes, x is your hypotenuse. So that's going to be the guy all by himself. So you're going to have 22 squared plus 27 squared equals x squared. Okay. Now, you might have to write this down. You might, by the end of class period, be efficient enough that you don't even need to write that down. Okay? But now, we're not going to write anything else down. We're going to go. Ready? 22 squared plus, you're in your calculator with me, right? 27 squared. And you get 1213. What do you do with that? Second square root. Second answer. Oops. So second square root, you should see a square root symbol pop up, and then second answer. Let's see if I can get that glare out of the way. So 34.83. Yeah. Yeah, so if you're seeing 34.82 in your calculator, you typed it in correctly. So x equals, I'm going to round that up though, 34.83. Okay, are we getting quick at that? So now let's talk about, how will I know if in my calculator I'm going to type in subtraction? What is she even talking about? Pythagorean theorem never has subtraction in it. You're right, the theorem itself does not have subtraction. How you do the problem has subtraction. So let's talk about this next one. This next one, your c squared is 9. Okay, so it would be x squared plus 7 squared equals c this time is 9 squared. Okay, we're going to solve that. So should I write down 49? No. Stick with me here. How are you going to move, if I'm solving for x, how are you going to move this 7 squared over here? You're going to subtract. Okay, so what are you going to type into your calculator? So again, you're going to get so good at this that you may not even need to write this down. But what we're doing on both sides is we're going to take that 9 squared and subtract 7 squared. Yes, sir?
So what keeps you from doing the square root of the whole thing and making it just x?
Because I want to make sure you're comfortable with this part first. But absolutely, if you want to, go for it. Now, the other thing is if you're simplifying the radical, you do want to see that number first before you square root it. So it just depends on your directions. So I understand what you're getting at. Can I put the square root in there first? Absolutely. Unless it tells you to simplify your radical. Okay? So I get what you're saying, but we're not there yet. Okay? Okay, so let's do this part. Let's go 9 squared minus 7 squared. I got 32, so I'm going to square root 32. So what Peyton was asking is, well, can't I just put a square root in the calculator at the beginning? And the answer is yes, you could. You could put a square root in there at the beginning. But what if I asked you to simplify this square root? Because this can be simplified into 16 and 2, right? And then the square root of 16 is 4 radical 2. You wouldn't be able to do that. because you wouldn't see that number 32. Okay, so here, now I need to square root that. So what I'm saying is if you needed to simplify your radical, you would want to see that the number was 32 so that you could break it down. Here, we're just worried about the decimal today because we already worked on simplifying radicals. So our decimal would be 5.66 if we round that up. Okay. Okay, especially this next one, number 4. On number 4, we've got 2 decimals already in the problem. There is no way you can simplify a radical that has decimals in it, so we are going to give decimals. When you type this into your calculator, do you know the answer? Are you going to add those 2 decimals together, or are you going to subtract them in your calculator? Do you know the answer to that? When you type them in, will you add them or subtract them? Do you know? You're going to subtract. If you don't know, it's okay. We're just trying to teach you some shortcuts, but if you don't know, it's okay. You just write it out. So this one right here, that's your c squared. So we'll go x squared plus 19.1 squared. 30.5 squared. Okay, so we're going to subtract this. So what I'm trying to do is I'm trying to get it so that these problems don't take you 5 minutes. Because if you were to type in your calculator 30.5 squared, write that number down. Then you type in 19.1 squared and you write that number down. And then you subtract them and you write down that number. And then you square root and then you write down that number. Okay, that just takes a long time and you don't need to do that. Okay, let's get faster, let's get quick, let's get efficient. So in my calculator, I'm going to go ahead and just type in, this is what I'm typing in. I'm typing in 30.5 squared. And you don't need to write this down necessarily. If you don't need it, you can go ahead and just type that in your calculator. And once I type that in, I'm going to square root to get my answer. Okay, but that's what I'm typing in. And we're just working on, that's your goal today. And when you're doing this homework, your goal is to just get efficient and get quick at doing those problems. Okay, so 30.5 squared minus 19.1 squared. So I get 565.44. So this is another reason it's nice to know that second square root, second answer, because second answer is 2 buttons I have to push versus typing in 565.44. Okay, there's a lot more buttons there. So we'll go second square root of my answer. So you can write that part down if you want. Later on in the unit, there are definite things that you have to write down in order to get credit for the problems, but this is not one of them. So if you can do this quickly, that's awesome. 23.78, if I round that up. Okay, now we get into some more interesting problems. Okay, so the next 3 types of problems that we're going to do are problems that involve the Pythagorean Theorem, but they involve something else as well. Okay, so we are going to do the Pythagorean Theorem, but we have to check out something else first. Okay, so the first one you're going to see, and this is a little bit of a typo, sorry about that, there needs to be a 90 degrees right there, otherwise we can't do that problem. So if you could put that on there for me, that'd be great. So this is an isosceles triangle. So what is so special about an isosceles triangle? In an isosceles triangle, these 2 little triangles on the inside here are congruent to each other. And if they are congruent, this entire thing being 22 means that each piece here is 11. So I can break that whole length into 2 smaller parts. Once I break that down, I now have a right triangle, and like I said, everything that we do in this unit is going to be with right triangles. There's a lot of fun stuff you can do with right triangles. Okay, so that right triangle right there, I can use Pythagorean Theorem to find the other side. I'm going to give you a minute. See if you can find it on your own. So we've got a 24 here, an x here, and 11 here. See if you can do it. 21.3 is what we got for our answer there. So we're going to do that. We're going to subtract. So we should subtract 24 squared minus that 11 squared. Okay, so that gives you that 21.3. Is that what I said? Yeah. 21.3? Okay, there you go. Okay, next one. We're going to slide over. This is a trapezoid. We don't know anything about trapezoids, but we do know about right triangles. We know how to do Pythagorean theorem with right triangles. So I'm going to make a right triangle. Where? Right here. So we're going to cut that trapezoid off, and we're going to make a right triangle, because I know Pythagorean theorem with a right triangle, so I can do that part. But what numbers do I use? Well, I don't want to use 18, because 18 was the entire thing. Okay, so we don't want to use 18. But we're going to use, not 18, because this is 5 over here. I got that from this number. So what's 18 minus 5? 13. Okay, and then whatever I get here for x is the same as the x on the other side, because basically what you made was a little rectangle, right? So that little rectangle, if you find x here, it's the same over here. Okay, so take a second. We've got one more Pythagorean theorem. We're going to get good at this. So take a second and do that Pythagorean theorem quick, and then we'll move on. It's just that it's not your fault. You're doing everything perfect. It's just that mode in the calculator. Okay, so really quick on this one, we'll type this in, and I want to show you we're struggling, and you're going to struggle with this when you get a graphing calculator as well, because you have to know how to change the mode of your calculator. So the mode button, which is the second one over, it says mode. If you hit that mode button, if yours happens to be in this math print, it won't give you a decimal. Okay, so you want to make sure that you're on classic mode. If you're struggling and it's like you're trying to get a decimal and it just keeps telling you the answer is radical 455, that's because we're in the wrong mode. But if that's happening to you and it's struggling, just raise your hand and I'll help. Okay, we can figure that out, but we just got to switch the mode over. That's it. You're doing everything perfect. It's just the calculator's in the wrong mode. Okay, so that one, if we have 16 squared minus 13 squared, and then we square root that, we got 9.33, if we round that, 9.33, if we round. Okay. Last one on this page, and then we're going to do a story problem, and then we'll move on to the second part, the last part of the day. So, this guy right here, it is super tempting. Oh, man, is it tempting. So tempting. You watch this, you ready? It is so tempting to do a squared plus b squared equals c squared. Isn't that tempting? It's got two sides, and I'm looking for the third side. Isn't that what I do? There's one problem. This is not a right triangle. Okay? So there's a reason, okay, at this point in your math career, they don't give you any numbers just randomly. So if there's an extra number and you haven't used it, it's there for a reason. So this number 12, we never talked about that one if we go a squared, b squared, c squared, right? So the thing is, we've got two triangles here. And yes, I want to find x, but you cannot find x yet. Okay, but what can I find? Given two sides, I can find a third side. Given two sides here, I can find the third side here. And to find x, I'm going to add them together. Okay, so we've got two numbers here we're going to do the Pythagorean theorem with, two numbers here to do the Pythagorean theorem with, and then we would add them together. Okay, so I'm just going to write that out, and then we're going to skip actually doing the problem. Okay, so the first one, because you're going to see something like this on your homework, and so this is just for the notes. We need to first find m and n and then we'll add them to find x. It's also possible that you'll have to find an m and then use that m in the next triangle to find x, something like that. But if there are multiple triangles within the picture, you probably cannot find x right away. You've got to find something else first. Okay, so just keep that in mind when you're doing multiple triangles put together. And we'll keep working on that. There's just one other piece we need to get to, so we're going to kind of skip all of that. There's a lot of work to get to that problem, and I know you know how to do the Pythagorean theorem with those two because we just did it twice. Okay, okay, turn the page. We're going to look at a story problem real quick. And again, we're just going to set this one up because we do want to get to that last chunk. We're just going to set these up, and then you'll practice the couple ones that are on the actual homework. Okay. Okay, so what you're doing on any story problem, 10 to 13, especially because we're just learning Pythagorean theorem, is you're setting up a right triangle. Okay, so you're setting up a right triangle, and then you're trying to find either the hypotenuse or one of the sides of that triangle. So, for example, on number 10, a roofer leaned a 16-foot ladder against a house. So, this is my beautiful artwork there.
Where's the door?
Oh, you know what? This is the side of the house that doesn't have a door.
So the window?
No, it's the garage.
Where's the side?
It's a barn that doesn't have windows. I don't know. So there's my house and there's my ladder. If it's a 16-foot ladder, where does the 16 go? It's the ladder. So we're going to put it on, it's actually the hypotenuse of my triangle. And then it says the base of the ladder is 5 feet away from the house. So the distance from the bottom, the base of the ladder, to the house, that's where I'm going to put my 5. And then it says how high. High is a vertical distance, so I'll put my x right there. And now we're ready for that Pythagorean theorem. Okay, so for these story problems, it's still the Pythagorean theorem. It's still doing what you've been doing, except you have to provide the picture first. Okay, you don't have to draw a fancy house like I did, super fancy, or a fancy ladder. You can just draw a triangle if you want. But for me, I'm a visual person, so it helps me figure out where the numbers should go. Okay, so if we did that quick, this would be a subtraction one again because I have the hypotenuse. Okay, if you're not sure, you can always write it out. Our c squared is 16, so it would set up like this. 5 squared plus, I said 5, but I wrote x. X squared plus 5 squared equals 16 squared. And then solve it through from there. So 16 squared, I'm going to subtract that 5 squared over. And I get 231. So x squared is 231. And the square root of 231 is 15 point, and it would be 20 if I rounded that up. And it would be feet. So it reaches 15 feet high. Okay. Okay, so the last part, and this is actually really important because there is a minimum distance for ladders for safety. There's like a minimum distance your ladder should be away from the structure you're leaning it against for safety reasons. So if you need to reach a 20-foot barn roof or whatever, what size of a ladder do you need, kind of a thing. So you can find that with the Pythagorean Theorem. All right, so the last part that we're doing, if you turn the page, the last page here, is called the converse of the Pythagorean Theorem. Okay, so I know I'm hitting you with a lot of information today, but tomorrow's a lot easier, so and we kind of have to make up a little bit from yesterday. So the Pythagorean Theorem converse. Converse means switch it around, right? Okay, so this is the theorem right here, and we're going to switch this around. If you are given a right triangle, then you're allowed to say that a squared plus b squared equals c squared, right? Switch that around. If a squared plus b squared equals c squared, then what kind of triangle can you call it? A right triangle. So right here for the converse, the one that we're comfortable with, and I'm going to write this backwards on purpose. It just makes it easier for the rest of it. So I'm going to write it as c squared. Then the triangle is right. Okay, so what we're going to do is we're going to come down to the three numbers that you're given, and you're going to test it out. Is c squared equal to a squared and b squared? What if the answer is no? Then what kind of a triangle is it? Okay, it's not a right triangle. That's right. But down here you can see that it does ask you if it's acute or obtuse. So how are we going to be able to tell that? Okay, so this part, again, visual person, so I need a visual. You ready? Okay, so in between my fingers is C. So we've got A, we've got B, and we've got C. You ready? So if C squared is bigger, what kind of a triangle am I making?
Obtuse.
Obtuse. So when C squared becomes bigger than A squared and B squared, what kind of a triangle is it going to be? Obtuse. So if it's not equal, okay, we have two other options. If it's not equal, then what if C squared happened to be bigger than a squared plus b squared? That would create an obtuse triangle. What if c squared was smaller? That is acute. Okay, so this is the last part that we're just going to practice for the next 2 or 3 minutes here. And then that's it. So we're just going to practice a couple down at the bottom, just to make sure we kind of understand how we figure this out. But there's a first check mark right here. It says it's not a triangle. How can it not be a triangle? Do you remember from last semester? Go ahead, Pete.
If the two sides don't add up to the big side.
So the two smaller sides have to add up to be bigger than the third side. So 3 plus 7, that's 10. Is that bigger than 9? Yes. Okay, so it's a triangle for sure. Now I can move forward. And the directions say that too. It says first determine if it's a triangle. Recall from earlier the sum of the two smaller sides. So it's right there if you forget. So you have to add the two smaller sides together, and it has to be bigger than the third. So let's look at the next one just to check. Is 20 plus 21 bigger than 29? Yeah, okay, so that one's going to be a triangle too. Let's check the next one. Is 4 plus 11, that's 15. Is 15 bigger than 16? No, so right away I can say that that's not a triangle. And because it's not a triangle, I can't tell you that it's an acute triangle because it's not even a triangle to begin with. Okay, so you have to check that first before you try to say that it's something else. Okay, and then we're only going to do the first 4. So 17 and 17, that's 34. 34 is bigger than 22, so that's definitely a triangle. Okay, so it says first determine if it's a triangle, which we learned last semester. Now we're going to use the Pythagorean theorem, okay? So c squared, so that's our 9 squared, is 9 squared equal to, so I'm going to leave a blank here because I don't know. Is it going to be equal? Is it going to be bigger? Is it going to be smaller? What's it going to be? So I'll leave a blank. So 9 squared, and I'm going to relate that to our 3 squared plus 7 squared. Okay, I got this one, 81. in your calculator, what is 3 squared plus 7 squared? Or if you can do that in your head, please feel free. What'd you get? 58. So c squared is bigger. And if my c squared side, this is c squared, is bigger, I say that this triangle is obtuse. Okay. Let me try again, just to make sure we're all on the same page. I'm going to take this 29 here. So 29 squared. How is that going to relate to, because I don't know, so leave a blank there. 29 squared. How is that going to relate to 20 squared plus 21 squared? So 841. And then 20 squared plus 21 squared. Ooh, it's 841 also. So if they are equal, you call it a right triangle. So if it's a right triangle, that's a Pythagorean triple, because those numbers nicely, right, make a right triangle. So the Pythagorean triple, 20, 21, and 29. Not a common one, like 3, 4, 5 is, but it is one. We get to skip over this one, because we already said it's not a triangle. So let's try this one. 22 squared. How does that relate to 17 squared plus 17 squared? 484. This is 484. Got this number yet already? 578. I need a fact checker, so thanks. Appreciate that. Just to make sure. So 578 is bigger, so my c squared is smaller this time. This is my c squared side. If c squared is smaller, like it says up at the top there, can't see it, but if c squared is smaller, we call it acute. Okay? So that's really the only new piece, because Pythagorean Theorem is not new, but it's good for us to practice it, and it's good for us to talk about it again before we move forward. So if you turn the page one more time, sorry, there it is. This page right here it does say it at the top, but this is our homework for the Pythagorean Theorem and its converse, okay? Tomorrow we're going to be doing another one of those radical days, okay, where we kind of do a practice one, and then I give you some time to do the problems on your own. So tomorrow there should not be homework unless for some reason we get out early and your guys' class is shortened. So there is a chance, especially if you guys have a shortened class tomorrow, that I won't have time to check this in, okay? So try to get as much done of it as you can, but I probably won't have time to check it in tomorrow if our classes get shortened halfway through the day. Okay?